It's time for Maths with Mr. Thomas.
I think perhaps you'd better both come inside. Chapter 3, lesson number 14, integration by parts. One of my favourite parts of the course. So, when we differentiate the product of two functions, what do we use, Keris? Perfect, you would use the product rule. However, when you integrate, obviously you cannot use the product rule. That's for differentiation. But we could use another method such as integration by substitution, and that is what we looked at in previous lessons. But there's another way of doing it as well. We can also apply what is known as integration by parts. Yeah. And you use integration by parts when one of the functions is very easy to differentiate and the other is easy to integrate. What you would do then is, if you're wanting to integrate, you would look for the function and take the part that's easy to differentiate and differentiate it. So you would have u, differentiate it to get u dash. Look for the function that's easy to integrate it, so start with v dash and integrate that to get v. Then the integral will become u times v minus the integral of u dash v. So you've got uv minus the integral of u dash v. The only place you've got a dash is for u dash just after the integral sign. Let's try some examples then. Example 1, use integration by parts to find the integral of x cos 2x dx. So we are using integration by parts, so we need to find one function that's easy to differentiate and another that's easy to integrate. What's the easiest one here to differentiate? Perfect, it will be x. So you would let u equal x. Look for one that's easy to integrate as well. Well, if x is the one that we're differentiating, then we would integrate cos 2x. So we would say v dash equals cos 2x. From there, to go from u to u dash, we differentiate. So if we differentiate x, we would end up with 1. And if we have v dash, then that's the one that we're integrating. So we're integrating to get to v. And if you integrate cos 2x, you would get, good, you would get sine 2x. But remember, you divide by the derivative of the brackets. And really, you're imagining that there are brackets around the 2x. So cos would go to sine, brackets would stay as they are, and then divide by the derivative. So it's a half sine 2x. From there then, if we are integrating x cos 2x, well, just look at the formula here. You would have u times v. So u times v would be, well, u times v would be x times a half sine 2x. Just put the half first, then the x, then the sine 2x. Take away, and then it's the integral of u dash times v. U dash is 1, so it's the integral of 1 times, and then a half sine 2x, which is obviously just a half sine 2x. And then you're integrating that with respect to x. After that then, well, you've got a half x sine 2x. That is not changing. But you can take that half outside the integral sign. So we've got to take away a half. And then if you integrate your sine 2x, I'm just ignoring the negative just now. I'm taking that to the side. I'm just writing that down as negative a half. And just integrate this sine 2x. Integrating sine, you will get negative cos 2x, but again, you're dividing by the derivative. So imagine brackets around the 2x, divide by that, so it's negative a half cos 2x plus c. And simplifying that, well, a half x sine 2x will just stay as it is. But because you've got the two negatives here, that will go to a positive, and a half times a half will be a quarter. And you've got the cos 2x plus c. Example 2, use integration by parts to find the integral of x sine 3x dx. So with this one then, Amar, help us out. What would you differentiate? X. Perfect, you would differentiate x, so let u equal x. And you also want to find the part of the function that's easy to integrate. If you've taken the x and you're differentiating that, well, you're left with the sine 3x. So to integrate it, you would start with v dash. So v dash would equal sine 3x, and you're integrating that. So differentiate u, du by dx, or u dash, would be 1. Integrate v dash, so if we integrate sine 3x, well, we know if we integrate sine, it goes to negative cos, so we'd have negative cos 3x. But what do you need to do? Good, you divide by the derivative. So we'd have negative 1/3 cos 3x. After that, the integral will be uv minus the integral of u dash v. So you can say that is u times v. So I'm just putting the negative 1/3 at the start, then the x, and then I've got the cos 3x. Minus the integral of u dash times v. And u dash is 1, so it's 1 times this part here. After that, what you can think is, ooh, look at it. In the middle, you've got two negatives. Well, the two negatives, so make that a positive. So take this negative outside the integral sign, and you would have negative 1/3 x cos 3x plus the integral of 1/3 cos 3x. You can then integrate. So negative 1/3 x cos 3x will stay as it is. The 1/3 will stay just as it is. And if you integrate cos 3x, well, you know if you integrate cos, you will get sine. So you'll have sine 3x. But what do you need to do? Good. Divide by the derivative of what's in the brackets. And you're imagining brackets around here. So you would end up with sine 3x, but you divide by 3. So we'd have another divide by 3. We'd have a third, and then sine 3x plus c. After that, just simplify it. So this first bit will just stay as it is. And then a third times a third is 1/9 sine 3x plus c. Example 3, use integration by parts to find the integral of x times e to the power of 4x. Again, you're looking at it, you're thinking, ooh, it's a product, I'm multiplying them together. Yeah. So what you need to do is look for one that's easy to differentiate and one that's easy to integrate. So what would you differentiate here, Syra? Perfect. I would do the same thing. So we're going to differentiate x. Nice and simple. If we differentiate x, u dash will then be 1. Good. And it means we're integrating then e to the power of 4x. So start with v dash, start with the derivative, and then integrate it, go back to v. To integrate e to the power of 4x, well, you know if you differentiate e to the 4x, it would just stay as e to the 4x, but you'd multiply by the derivative of the index. You want to reverse that, so e to the power of 4x will still stay as e to the 4x, but this time you would divide by the derivative of the index. We'd have a quarter e to the power of 4x. After that, the integral will become, well, we've got u times v. So you've got x times a quarter e to the power of 4x, just putting the number first, then the x, then the e to the 4x. And we are taking away u dash times v. U dash is 1, so it's 1 times a quarter e to the power of 4x. So it's the integral of a quarter e to the power of 4x. To integrate that then, well, you've got a quarter x e to the power of 4x. That would just stay as it is. You are taking away, just take the quarter outside the integral sign. And then if you integrate e to the power of 4x, well, integrating e to the 4x, once again, we've just done it. So you'd have e to the power of 4x, but you would divide by the derivative. So we'd have a quarter. We're dividing by 4. So you'd have another quarter and then e to the power of 4x. And in the end, you always have plus c. Simplify that. So you've got a quarter x e to the power of 4x. Take away a quarter times 1/4 is 1/16 e to the power of 4x plus c. And that is your answer. Example 4, use integration by parts once again to find the integral of 2x plus 1 times e to the power of 2x. You're looking at it, you're thinking, ooh, it's a product, I'm multiplying, so I need to integrate, and I'm using integration by parts. So find one part that's dead easy to differentiate and another that's easy to integrate. What would you differentiate here? What is really, really easy to differentiate? Good, the 2x plus 1. So differentiate the 2x plus 1. If you do that, you will get 2. So start with u, which is 2x plus 1. U dash will be 2. The one that's easy to integrate then will be the e to the power of negative 2x. And if you integrate e to the anything, it stays as e to the anything. However, you always have to divide by the derivative of the index. And in this case, that would be negative 2. So we divide by negative 2. Just moving that to the front, and we've got negative a half. Taking a half is the same as dividing by 2. From there, the integral will be, you've got uv minus the integral of u dash v. So you would have u times v. So I've got this negative half e to the power of negative 2x times this 2x plus 1. Putting the fraction in the negative first, then putting this bit just in brackets, the 2x plus 1, and then putting the e to the negative 2x. So we're writing it with any numbers, then I've got any x terms, and then I've got any exponentials. From there, I would take away the integral of u dash times v, and u dash is 2. So it's the integral of, and if you work this out, well, you've got 2 times a half, which is just going to be 1. The negative would stay, so it would be negative 1 times e to the power of negative 2x. From there, well, you've got this negative a half, 2x plus 1, e to the power of negative 2x. You know your two negatives would make a, you got it. And if you integrate e to the negative 2x, well, you can write that down first of all. So that will then give you, integrating e to the power of negative 2x will give you e to the power of 2x, but you have to divide by the derivative of the index. So we're dividing by negative 2. So this plus will become a negative because it's a negative half. And don't forget your plus c. Example 5, use integration by parts to find the integral of x cubed, ln x. Again, you want to find one part that's easy to differentiate and another that's easy to integrate. So what one would you differentiate here? Some people saying x cubed, some people saying ln x. Well, think about it. Those of you who would differentiate x cubed would integrate ln x. What do you get if you integrate ln x? Dun, dun, dun. Exactly, it's confusing. Really, you would have to, in this example, differentiate ln x because the integral of ln x is unknown. We don't know how to integrate ln x, so we would just leave that as the one that we differentiate. So u would have to be, in this example, ln x, and v dash, the one that we integrate, would have to be the x to the power of 3. U dash then, if we differentiate ln x, what would you end up getting, Connor? Good, 1 over x. And if you integrate x to the power of 3, perfect. That would be x to the power of 4 over 4, or a quarter x to the power of 4. From there, the integral then will be u times v minus the integral of u dash v. So u times v will be a quarter x to the power of 4 times by the ln x. And I'm taking away the integral of u dash times v. So I've got 1 over x times by a quarter times the x to the power of 4. So the quarter, I'm just putting that at the start, and then I've got 1 over x times x to the power of 4. Well, this means divide by x, so if I divide this by an x, I'm left with x to the power of 3. To integrate to that then, well, I've got a quarter x to the power of 4 ln x, and I'm taking away, well, let's leave a quarter just as it is, and if you integrate x to the power of 4, x to the power of 3, it goes to x to the power of 4. But again, you would divide by 4, so you're bringing in that quarter as well. And you've also got plus c. Simplify that, well, you've got a quarter x to the power of 4 ln x. Take away a quarter times a quarter is a 16th x to the power of 4 plus c. And that would be your answer. Example 6, use integration by parts to find the integral of 1 over x to the power of 4 ln x dx. Similarly to the last example, well, in the last example we had to differentiate ln x because the integral of ln x was unknown. It's the exact same here. So we have to differentiate ln x, which means u would be ln x. U dash then, if we differentiate ln x, that is 1 over x. Good, 1 over x. And v dash then has to be 1 over x to the power of 4. To integrate that, you would rewrite it, move the x to the top line. And that'll be x to the power of negative 4. Good. Integrating then, add 1 to the power, divide by the new power, would give us x to the power of negative 3 over negative 3. And then if you rewrite that, you can move the negative index to the bottom, so you'd have a positive index. So it's negative 1 over 3x to the power of 3. To integrate, you apply uv minus the integral of u dash v. Remember, the only place there's a dash is just after the integral sign with u dash. So you've got u times v. So you've got this negative 1 over 3x cubed times ln x. You are taking away the integral of u dash times v. And u dash times v, well, the negative will be there. And then you've got 1 over 3x cubed times 1 over x. Well, you've got the two fractions this one, and this one being multiplied together. So 1 times 1 will leave you with the 1, and then 3x cubed times x will be 3x to the power of 4. After that, you could think I've got 2 negatives in the middle. 2 negatives, make it positive. So you can write that as plus. After that, to integrate 1 over 3x to the power of 4, well, you may wish to write that as 1/3 x to the negative 4 to make it easier for yourself. So the first part is just staying as it is, and then I've got the 1/3 and I'm moving that up so it's x to the negative 4. You know to integrate that, well, you're keeping the first part, the negative 1 over 3x cubed, ln x, plus, if I take that third outside, or I'm just writing down 1/3, and then if I add 1 to the power, so x to the negative 4, add 1 will be x to the negative 3, but I'm dividing as well by that negative 3. So I'm bringing in that other fraction. From there then, you've got the 3 times the negative 3, which will mean that that plus will become a minus, and 1 over 3 times 1 over 3 is 1 over 9, and you've got x to the negative 3 plus c. After that, you could take that one step further. You've got a negative index here for x cubed, so if you move that to the bottom line, you've got negative 1 over 3x cubed, ln x, take away 1 over 9, and just move that x to the power of negative 3 down to the bottom, so you've got the x cubed, and then you've got that plus c. Example 7, use integration by parts to find the integral of x times 2x plus 1 to the power of 4. Again, it's integration by parts when one part is easy to differentiate and another is easy to integrate. So which one would you differentiate here? What do you think, Eduarda? Perfect. I would differentiate x as well. It's dead easy. It just goes to 1. So u is going to be x. And if you differentiate that with respect to x, you get 1. Which means then that the one we are integrating is 2x plus 1 to the power of 4. So 2x plus 1 to the power of 4 would be v dash. Integrating v dash will take you back to v. And if you integrate, well, you would have brackets to the power of 4 would become brackets to the power of 5 over 5. But what do you need to do? Good, divide by the derivative of what's in the bracket. So you'd have a half times that 2x plus 1 to the power of 5 over 5, which you could then simplify to, if you put the half and the fifth together, that'd be 1/10 2x plus 1 to the power of 5. To find the integral, it's uv minus the integral of u dash v. So u times v will be x times this part down here. So we'll have 1/10, putting the number first, then putting the x, and then putting this 2x plus 1 to the power of 5. I am taking away the integral of u dash times v, and u dash is 1, so it'll be 1 times a tenth, 2x plus 1 to the power of 5. So 1/10, 2x plus 1 to the power of 5 dx. To integrate that, well, you've got the first part is just staying as it is, it's not changing. Then you've got take away. 1/10 will stay as 1/10. 2x plus 1 to the power of 5, if you integrate that, it goes to 2x plus 1 to the power of 6. But you would then divide by 6. And also, when you do this, you've got the divide by 6, so 2x plus 1 to the power of 6, divide by 6. But you've also got to divide by the derivative of the brackets. So you're also bringing in that half. So a tenth is staying as it is. Divide by the derivative of the brackets gives you the half. And if you add 1 to the power and divide by that power, it gives you the sixths. And you've still got the 2x plus 1 to the 6 plus c. Obviously, don't leave it here with 1, 2, 3 fractions. Simplify all that. So you've got 1/10 x, 2x plus 1 to the power of 5. And then multiply numerators and denominators gives you take away 1 over 120. 2x plus 1 to the power of 6 plus c. Example 8. Use integration by parts to find the integral of x times the square root of 2x take away 1. Again, you want to look for one part that's easy to differentiate and one that is easy to integrate. So which one would you differentiate? Good. Go with the x. It's nice and simple. So differentiating x gives you 1. Perfect. And then integrating, well, you'd integrate the square root of 2x take away 1. Just remember that would be written as 2x take away 1 to the power of a half. Perfect. Integrating that then, so going from v dash to v, you would add 1 to the power and divide by the new power. So add 1 to the power gives you 3 over 2. Divide by 3 over 2. If you flip that upside down, it's the same as multiplying by 2 over 5. But you need to again divide by the derivative of what's in the brackets. Here you've got a 2, so you'd also divide by 2. So we've got the half. Add 1 to the power gave us 3 over 2. Flip it, that would be the same as times by 2 over 3. We've got the 2x plus 1 to the power of what's now 3 over 2. If you rewrite that, well, you've got the half times the 2/3, which will give you 1/3 if you multiply them. And then you'd have 2x take away 1 to the power of 3/2. The integral will be u times v, so it is x times by v. So it'll be x times that 1/3, 2x take away 1 to the power of 2/3. When I write that, just put the number first, put the third, then write down the x, then write down the 2x take away 1 to the power of 3/2. I am taking away the integral of u dash times v, and u dash is 1, so that makes it really simple. So it's just 1 times v, so it's the integral of all of that. After that, the first part will stay as it is, so you've got 1/3 x, 2x take away 1 to the power of 3/2. Take away, 1/3 will stay as 1/3, and integrating, that will give you, well, 3/2 add 1, 3/2, 3 add 2 is 5, so it's 5/2, and I'm dividing by the 5/2. But remember, you also have to divide by the derivative of the bracket, so I'm also going to divide by 2, or in other words, multiply by a half. Remember, this went to 2x take away 1 to the power of 5/2. Dividing by 5/2 is the same as multiplying by 2/5. And the brackets would be as they are, and as I said, it's the 5/2. Simplify this, well, the first part is staying as it is, nothing's changing, but I've got 1/3 times a half times 2/5, multiply the numerators, multiply the denominators, and then simplify, and it gives you 1/15. 2x take away 1 to the power of 5/2. And always remember, you need your plus c. Example 9, use integration by parts to find the integral of x over the square root of x plus 4. So with this one, again, what you need to think is, well, the product rule is used when you've got the product of two functions, but here really it's the quotient that you've got is x divided by the square root of x plus 4. But what you could do is you could think, right, well, instead of writing it as that, I could write it as x times 1 over the square root of x plus 4. Or you could move the x plus 4, if you write that as x plus 4 to the power of a half, and then move that to the top line. So it'll be x plus 4 to the power of negative 1/2. Therefore, you'd have really x times the square root of x plus 4, or x plus 4 to the negative 1/2. So it would become a product. So u here, the one that's easy to differentiate, is obviously x, and if you differentiate it, you get 1. Makes it nice and simple. But as I said, if you took x to the side, it would be x times 1 over this. So you're thinking, well, it's 1 over that. Or, as I said, you could write that as a power of a half, move it up, and it'd be negative 1/2. So you can think about it either way, as long as you get down to that. That is what v dash will be. We will integrate it to get v. So if you integrate, you add 1 to the power, so that goes to the power of a half. Divide by the half is the same as multiplying by 2. So it'll be 2 times the x plus 4 to the power of 1/2. And if you rewrite that, well, that'll be 2 times the square root of x plus 4. You are thinking then the integral is given by u times v minus the integral of u dash v. So you're going to have u times v will be x times this. So write the numbers first, then write the x, then root x plus 4. Then take away the integral of u dash times v. So it's the integral of 1 times this, the 2 root x plus 4. So it's just the integral of 2 root x plus 4. The left hand side, this part will stay just as it is. And then I will have a takeaway. Integrating that, well, you know you need to write that as 2 times x plus 4 to the half, first of all, before you do anything. And if you do that, well, you'll have the negative 2, that will stay. X plus 4 to the power of a half, if you add 1 to the power, it goes to 3/2. Divide by that 3/2 is the same as multiplying by the 2/3. And you'd have the x plus 4 to the power of 3/2 plus c. Woo! And from there you can simplify that. So we've got 2x root x plus 4. Take away 2 times 2 is 4, so it's 4/3 times by the x plus 4 to the power of 3/2. And again, it's plus c. Yeah. Example 10, use integration by parts to find the integral of ln x with respect to x. Hold up! Wait a minute! It's integration by parts, and we know integration by parts is used when we have the product of two functions. Here it's just ln x. Mamma mia! What do we do? Well, the first thing we need to do is we need to write that as a product. Anybody have any ideas how we could write that as a product? Perfect, well done. ln x is the same as 1 times ln x. Nice and simple. So integrating ln x dx, well, ln x is the same as 1 times ln x. So really you're integrating 1 times ln x dx. From there you've now got a product. You're multiplying two parts together. You're multiplying the 1 by the ln x. After that, you need to decide which one are you differentiating, which one are you integrating. Well, if we knew what ln x is if we integrate it, we wouldn't be doing this question. So ln x really is the one that has to be differentiated because the integral of ln x is unknown. So you would differentiate ln x. And if you differentiate ln x, you get 1 over x. Perfect, you get 1 over x, which means then you would integrate 1. And if you integrate 1 with respect to x, it's just x. From there then, using this funky wee formula, you've got u times v, so ln x times x. Just write that out as x ln x, so it doesn't look like ln x squared, because that would be totally wrong. You are then taking away the integral of u dash times v, and u dash is 1 over x, and you're timesing that by x. From that though, well, if 1 over x times x, well, you're dividing by x, you're timesing by x, so the x's will cancel out, leaving you just with the 1 just there. After that, you can integrate, so x ln x will stay as x ln x. And if you integrate 1 with respect to x, you would get x. Perfect. And you'd have plus c. So that would be your answer. There are 10 examples of integration by parts. Once you master them, once you're confident with it, practice the questions on page 75. And if you feel you're okay with integration by parts, move on to the next lesson, which is looking at harder examples using integration by parts. Best of luck. Just remember this amazing wee formula. Best of luck. Again, have fun. Bye.